Bismillahirrahmanirrahim. Welcome to Glenrich Maths. Today we are going to solve a question on finding the equation and midpoint of a tangent to the curve. And the question belongs to paper 060612 for the session October-November 2024. And you can see that on the display I wrote my WhatsApp number so that you can let me know a question where you have faced a problem. So please let me know that a particular question should be solved which seems to be difficult to you. Well, let's go to our question today. The question is, this is question number 8, and it says the tangent to the curve y equal to e raised to x into 2x plus 5 raised to half at the point where x is equal to 2 meets the x-axis at the point x and y-axis at the point y. Find the coordinates of the midpoint of xy, giving you answer in exact form. Actually, the question is very abstract, so apparently it seems to be very complicated. It will be very easy and convenient for us if we can sketch the scenario actually. So look at this, there is a curve. Let's sketch the curve. It is not exact sketch or drawing. We are going to just assume that the scenario is, this is our quadrant. So the curve, suppose the curve is a complex curve. Let's see, it may be this way. Okay, suppose this is the curve. Let me draw a little more appropriate this way. Okay, then there is the tangent. So our clue point is tangent. Tangent may be this one is the tangent. So the tangent is intersecting x and y. Look at this here, this is x-axis, isn't it? This is x-axis. Okay, so it touches at x-axis. Suppose this is our a. Okay, and it intersects at this point on y-axis. So this is how the scenario is, and they have told us to find this point, the midpoint. The midpoint will be, suppose this is our line AB, and we will find the midpoint. So how to solve it mathematically? First of all, we will opt for derivative, because whenever tangent is mentioned, tangent is a straight line. Look at this, this is AB is the straight line. For straight line, for forming an equation of straight line, we require the gradient, and gradient, as the tangent is intersecting at one point, as tangent is intersecting the curve, so definitely the gradient of the curve must be the gradient of the tangent at a particular point. They have told where x equal to 2. Okay, when x is equal to 2, so gradient of both the curve as well as the tangent will be same. So let us find the gradient of the tangent, and gradient means, the derivative. So let us find the derivative of the curve. Our function is actually y equal to this is our function. Okay, so we have written here y equal to e raised to x into 2x plus 5 raised to half. Then we will find how to find the product of the derivative of two functions which are in multiplying state. This is one function, another one is this. Let us see how to find the product of two functions, derivative of the product of two functions. Let's say x and y, or u or b. V are the two functions, they are in multiplying state, and we are going to find the derivative of uv with respect of x. Sorry, let me erase this. Let's say u and v are two functions, okay, u and v, and we are going to find the derivative of u and v with respect to x. Okay, so derivative of u, first of all we will write v into d over dx of u plus, then just a reversal of that. First we have started with v, now we will write u, d over dx of v. So simple way, the second function is written always first, then the derivative of the other one, then alternated way the first function into the derivative of the second function. So very simple. First we will write the second function into derivative of the first function plus first function into derivative of the second function. The same way we have written over here, we can see here. Yes. So we have written our y is here. This is the first function. Okay. This is e raised to x is the first function, and second function is 2x plus 5 raised to half. So we have written dy over dx equal to the first function. I mean, sorry, second function. Second function into derivative of the first function. Then just alternate first function into derivative of the second function, as I have explained just now. Then we will find the derivative. So the simple way of finding derivative is derivative of e raised to x. Look, e raised to x is actually unchanged because here coefficient is 1. Okay, and not coefficient is 1, as well as exponent is also 1. Exponent is also 1. So if you multiply this 1 into 1, it is 1. That means e raised to x remains unchanged in case of derivative. Then the first function, it is also unchanged. So we have written the first part. Then for the second part, we'll have to differentiate this. For differentiation, first of all, we will write the exponent. Look, exponent is half. We have written here half into, we will have to differentiate the inner function. Look, inner function is 2x plus 5. So 2x plus 5, if we differentiate it, it will be actually just 2. And the exponent of x will be 0. That's why it's unnecessary to be written, and derivative of any constant number is 0. So ultimately derivative of 2x plus 5 dx d over dx of this is actually 2. So we have written first the exponent. Exponent is half. Look, this is half. Then we have differentiated the inner function, which has brought 2. We have written here 2. Then this function remains unchanged. We have let it remain unchanged. Then exponent. Exponent is negative half. So let me explain this again in a new page. So this is our function, and we are going to differentiate this. First of all, what will we do? We will write the exponent. Exponent is half, this one. Okay, then we will differentiate this inner function. Inner function is 2x plus 5. For 5 it will produce 0, and the derivative of 2x is 2. So we have written 2. So first we have written the exponent, then we have differentiated the inner function. After that, the function will remain same, but there will be the decrease in the exponent. Exponent always is decreased by 1, so half minus 1. Okay, ultimately what is it going to be? To dissolve this 2, then there remains 2x plus 5, and exponent, if we subtract 1 from half, it will be negative half. So we have got that the derivative of this function 2x plus 5 raised to half is 2x plus 5 raised to negative half. So just we have written the same answer over here. Let's go back to this. Here we have written, look at this, the derivative of this one. Let me erase these unnecessary parts. I am retelling whole of the function. Here the derivative of e raised to x is unchanged, and as we are doing nothing to the first function, it has also remained unchanged. About the second one, already I have shown how to differentiate this function. First we have written the exponent, then we have differentiated the inner function which has produced 2, then the function, the whole function, and exponent has become negative half, because if we subtract 1 from half, it is negative half. Then this is the function, this function has remained unchanged. Well, after that, if we dissolve this 2 by this 2, the first function, when exponent is half, this exponent is actually half, isn't it? This exponent is, yes, this is exponent half. Exponent half means this is actually square root. So we have written here e raised to x, and 2x is square root over 2x plus 5. Then for the next one, this is also square root is half. Let me erase again. For the second function, as this has gone away, so there remains 2x plus 5, but exponent is negative half. Negative half means this is denominator. Okay, so we have written square root as denominator, 2x plus 5, and this e raised to x, this is definitely numerator, it should not go down. So what have we got? E raised to x over square root over 2x plus 5. This square root over here, this is numerator because the exponent is positive, but here the exponent is negative, that's why it will be the denominator. Let's see the next step. So ultimately, if we simplify, it will be LCM will be this will be LCM, and then if we multiply this root over 2x plus 5 into root over like this one, root over 2x plus 5, if it is multiplied, it will be whole square, isn't it? So square and square root, they can cancel out each other, so there will remain only 2x plus 5. So here we have written 2x plus 5 along with e raised to x, this one. Then plus here 2 raised to, if we multiply this 2 raised to x, this is square root over 2x plus 5, this one is also square root over 2x plus 5, so after division it will be 1. If we multiply 1 by e raised to x, it will be e raised to x. So we have got, this is our derivative, or dy over dx. Let me show you after erasing. Yes, this is our derivative. Then if we do simplification, it will be 2x, just here multiplication. Okay, this, if this function has been multiplied by e raised to x, and this is unchanged, so ultimately it is going to be, denominator is unchanged, so 2x e raised to x, this one, 2x e raised to x, and 5 e raised to x, and another e raised to x. Well, now we are actually finding the gradient. Let's go back to the question again. What was the question? The question was to find the tangent to the curve, and for forming the equation of tangent, we are just searching for the gradient. Gradient means derivative, so dy over dx. Now they told that gradient at every point is not same. They have told us to find the gradient at this point. Okay, we require the gradient at this point when x equal to 2. When x equal to 2, we have written here, when x equal to 2, when x equal to 2, when dy over dx is equal to this is our derivative. Okay, we have written first 2, this 2, then x is equal to also 2, then e raised to x means 2, x means 2. After that there comes plus symbol, we have written plus. Let me erase these unnecessary parts. Then there comes 5, we have written here 5, this 5, then e raised to x is equal to 2, so we have written 5 e square, then e raised to x is equal to 2, already we have written x equal to 2. Then what is it going to be? Let me show you the later part. It is going to be 2 2s are 4 e square plus 5 e square, that means 4 plus 5 9 e square, and then e square, that is 10 e square. What about the denominator? Denominator, this 2 into x means 2, so 2 2s are 4, 4 plus 5 9, so denominator is going to be actually square root over 9 over here 2 2s are 4, 4 plus 5, 5, that is 4e square plus 5e square plus e square, total 10e square, 10e square. And square root of 9 is actually 3, so it is going to be actually 10e square over 3. Look, this is the gradient we have obtained. I have written it just beside this. Yes, so our derivative is this one. This one is our derivative. So this is the gradient for the tangent. Since the beginning I have told here our AB is the, look at this, AB is the tangent. Okay, then for AB we should know the gradient for forming the equations. Okay, we have come to know the gradient of AB. Now if x is equal to 2, we should know at this point wherever x is 2, we should know the coordinate of y also. So we have written here x equal to 2 when y is equal to, y is the our function over here. This is our function, y is equal to e raised to x into 2x plus 5 raised to half. So we are going to find our corresponding value of y. We have written here that x equal to 2 when y is equal to e raised to it was x, so it is 2. Then 2 into x means 2 plus 5. So ultimately it is getting y square into 2 2s are 4 plus 5 9 raised to half, and 9 raised to half means actually 3. That's why this is 3 e raised to 2 means 3e square. It is 3e square. So 3e square is the value of y, whereas the value of x is 2. So we have got a coordinate of this equation of the tangent. Look, x is our now coordinates. Coordinates has become x equal to 0, x, y. Okay, x, x, y, x, y. X was 2, or let me write it just below this, x is 2. Okay, and y we have obtained is 3e square. So using these 2 points from the graph, if we show, suppose this one here x is equal to 2. Okay, suppose here x equal to 2, this is the, suppose this point is the, let me mark it with different ink here. Okay, suppose we are talking about this point. Okay, at this point x equal to 2, x equal to 2, y is equal to 3e square. Okay, yes, this is the coordinate of this point. Okay, now using this we know the gradient, we know this these two coordinates, so we can easily form the equation. That's why we have written here the equation is equation of the tangent. Tangent, what is the name of the tangent? We have written here tangent is AB. Look, this is our tangent. Okay, this is our tangent. This will extend like this. So our tangent is AB. Here we can include one sentence, one word, that equation of the tangent AB is. Okay, it is not given in the question, but we supposed it to be AB. So you know how to form the equation. Equation is y minus y coordinate in equal to the gradient into gradient. This is the gradient. Already you may remember that 10 e square over 3 is the gradient, then x minus x. So y minus y coordinate is equal to gradient into, it is actually like this. When y is equal to mx plus c. Okay, this is the form of any equation of a straight line. So y minus 3y square is equal to 10, and this is gradient into x minus x coordinate. Then in the next step what have we done? We have just transposed this 3 e square on the right side. Otherwise, look at this, left side there is y, and this quantity, if x is multiplied by them, then it is going to be 10 e square x over 3. Then this 2 will also multiply, this 2 tens are 20 e square over 3. Then from left side it has been brought to the, shifted to the right side. So this is 3a square positive. Ultimately we have got y is equal to 10 e raised to x over 3 minus 11 e square over 3. So we should not forget that this is the equation actually we are searching for. This is the equation. So using this equation, and our, what was our basic question? Our basic question was that find the midpoint. Look at this. Find the coordinates of the midpoint of xy. Okay. Oh, sorry, this is actually x. They have termed this as x. This is x and this is y. Okay. So our tangent is xy. Now for this xy, we'll have to find this midpoint. Okay. If we know the equation of that, of any line, then it is very easy to find the midpoint. So let me write here, instead of AB, as they have mentioned that it is not AB, it should be xy, actually xy. Okay, xy. And we have formed the equation of xy is this is the equation. Now we will apply the value of the x and y on these equations. Okay, let us go to the next part. It's written on the next page, I believe. Yes, over here. Now we will have to know one thing. Let me show you once again. Here, look at this. They have told that, let me draw the graph on the next page again. Here, yes. So this may be our graph. Then we are actually, what do we need? They told us to find that this is xy. Okay, xy, this is the tangent, or xy, whatever. X is over here, y is over here, and they have told us to find actually the midpoint. Midpoint is over here. So if we observe carefully, we will find that here our x coordinate is missing, y coordinate is 0, y coordinate is 0. Okay, and here our, at this, on the y axis, our x is 0. Here x is 0, but y is to be obtained. So let's see how can we find. On the x axis, y is always 0. We have written here on x axis, it is written on x-axis, y is equal to 0. So y equal to 0 when our y means our equation. Have we forgotten our equation? Our equation was this. Let me show you. This was our equation. What was our equation? Y equal to 10 e raised to x over 3 minus 11 e square over 3. So as y is equal to 0, so whole of this will be 0. That's why we have written here that, over here, that this equal to this equation is equal to 0. So whole of this is equal to 0. Okay, if we simplify, what will happen? We can combine the both the functions. So 10 e square x minus 11 e square. Then by doing cross multiplication, it is actually 0. On the left side here there is 1. So by 1, if we multiply, it will be 10 e square x minus 11 e square is equal to 0. Then from both of the quantities, we can take e square x is common. Look, e square is common. E square is common. So we have taken e square as common, and if a square goes away, then that remains 10x. We have written here 10x minus 11. Okay. Now e square is not equal to 0. It's not possible, because it's a it's Euler number. Euler number is more than 0. So this cannot be actually 0. Okay, that means this factor is equal to 0. If 10x minus 11 is equal to 0, so definitely our x is actually 11 over 10. So we have got the x coordinate. Okay, x coordinate is this, and y coordinate, in the at the beginning we have told y is 0. Y is 0. We have told y is 0 and x is this. So coordinates of x are this. We have obtained coordinates of x is 11 over 10 0, and here we have just shown here. So coordinates of x is 11 over what? It is 11 over 10. Yes, this is the coordinates of x. Okay, 11 over 10 0. So here we will just write 11 over 10 0. X coordinate is 11 over 10 and y coordinate is 0. Now the turn of finding the y coordinate of y, that means this intersecting point. So here, what on the y-axis we know x is equal to 0. If we substitute x equal to 0, we will find the y coordinate. Here it is written x is 0 on y-axis. Look at this. This is the notation. X is 0 on y-axis. So if x is equal to 0, then y, this is the whole of our y. Okay, y function is this. So y equal to x is equal to 0 means 10. If it is 0, let us see, x is 0. Okay, x is 0. So it was actually our 10 e raised to x. Okay, so e square into 0, actually e square x, it was 10 e square x. Our, let us see our function. Our function was, what was our function at the page number 2? It was 10 e raised to, look at this, this is our function, 10 e raised to x, e square x over 3 minus 11 e square over 3. So 10 e square x, 10 e square x is this at this page, 10 e square, 10 e square, and x is our 0. So ultimately it is going to be 0. 0 over 3 means 0, and this one is unchanged, 11 e square over 3. So ultimately our y is, what is our y? Y is negative 11 e square over 3. Our coordinates of y are 0, negative 3, negative 11 e square over 3. So let us write it over here. We have got that y coordinate is negative, negative 11, negative what, 11 e square, negative 11 e square over 3. So we have got these 2 points. They have told to find the midpoint of xy. So x coordinate of x is this, and coordinates at y is this. Now midpoint, you know, we will add up this one. Let me show with different, this one plus this one divided by 2. Same goes this one plus this one divided by 2. We will add up x plus x, that means both the x coordinates would be added, and it will be divided by 2. Because we are searching for midpoint, we should not forget that midpoint. Okay, to find the midpoint, we will add up both the x coordinates divided by 2 as well as both the y coordinates divided by 2. So let us write, let us see here. Yes, so we have written here midpoint of, midpoint of the line xy is, line xy is what? So first, coordinates, just, yes, yes, now you can see more visibly. Yes, well, so here our x coordinate is here 0. Okay, and here x coordinate is 11 over 10. So we have written here 11 over 10 plus 0 over 2 for midpoint. And again for y coordinate, this is the first y coordinates, negative 11 e square over 3 plus 0, plus 0 over 2. Now ultimately it will be 11 over 10 into half, and 11 e square over 3 into half, means 11 over 10 minus 11 e square over 6. So this is ultimately our solution, that the midpoint of the tangent. Now let me show you the whole picture together so that you can copy it. Yes, this is the first part of the solution. So if I recap, I will tell that, let me erase something from here also. So by zooming it out, I can show you the question once again. They told that the tangent to the curve, tangent to the curve y equal to something at the point where x equal to 2 meets the x-axis at point x and y-axis at point y. Find the coordinates of the midpoint of xy, giving you answer in exact form. So what was the concept? First, we assumed that this is, we assumed that this is our, sorry, this is our curve. Okay, we assumed that this is our curve, this is our curve. So in this curve, the tangent is this. which intersects x-axis at x, means here x, and y-axis at y, here y. Then they have told us to find midpoint. So for finding midpoint, first of all we'll have to know the equation of y, and for equation of the tangent we should know the gradient. Okay, we should know the gradient. So how can we find gradient? Gradient is nothing but the derivative of the function. So we have got the derivative of the function first, dy over dx. Here you can see dy over dx is this. Then they have told when x is equal to 2, when x is equal to 2, because they have told at x equal to 2 we will have to we got the coefficient. That means the tangent touches the curve when x equal to 2. That's why we have substituted x equal to 2, and we have got the derivative is actually this is the derivative. So when derivative is this, we should know x is 2, which is known to us. Then we should know how much is the y coordinate when x is 2. So we have got the y coordinate also. Then our x coordinate is 2, x coordinate is 2, y coordinate is 3 e square. So using these two coordinates we can form the equation y minus y coordinate equal to gradient into x minus x coordinate. Ultimately we have got the equation. So whenever we get the equation, it becomes very easy for us to find the midpoint or any other point. And they have told that the tangent intersects the x-axis and y-axis. That's why we have drawn another figure over here. Suppose this one, this may be the curve, and our tangent is this, and sorry, not this way, this will go this way. Okay, somewhat like this, not like this. uh, Yes. So this way, this is our x coordinate, I mean x, this is y. And we are searching for the midpoint at this. Okay. Already we have formed the equation of this line yx. The equation is this. This is our equation on the previous page. Yes. This is our equation. Okay. So this is the equation. And as it is intersecting at x, so this point, at this point, y is 0. We have written here on x-axis y is 0. Well, so y is 0. Here if y is 0, then our x is this. This is the x coordinate. This is our x coordinate. So we have got the x coordinates as well as y coordinates of this point. Okay. Then we have found the x coordinate and y coordinates of this point. Let me show it through different this point as well as this point. Okay. Then we have found the midpoint. Midpoint means just adding up both the points and dividing it by 2. So I tried my level best to explain it as per my capability. If it benefits you in the least bit, then I will be thankful to Almighty Allah. For if you want to face any problem, if you face any problem in any of the solutions, please let me know. I will try to solve that and explain the confusing points. So Allah Hafiz.